Eyes up here, okay? Inverse trigonometric functions. On Friday, we talked about this. Y is equal to sine of x, and y is equal to arc sine, which is sine inverse of x. And what happens is we looked at the domain. For example, domain was all real numbers for this. But the range output, sine, what's the biggest value that sine can be? What's the smallest value? So -1 to 1 was the range for sine of x. Well, what happens is when you take inverses, the domain and the range switch. So the domain becomes -1 to +1. And the range output, in order to make it a function, is just narrowed to -π/2 and +π/2. What the heck does that mean? What it means is this. For what angle is sine equal to 1/2? Starts with a TH, rhymes with 30. 30 degrees. Is 30 degrees between -90 and +90? Yeah, that's what your calculator is going to spit out. Also, sine is equal to -1/2 at two spots. At 210 degrees and at 330 degrees. The problem is that it's not, neither one of those angles is registered between -90 and +90. So what does it choose? It chooses -30 degrees. So what we tried to focus on Friday was helping you understand why your calculator chooses the values it does. So I'll just go through a couple more. Again, if we go sine inverse of 0.5, you can see you get 30. If you go sine inverse of -0.5, you get -30. Cosine is different. It will also take in values between 1 and -1. So for example, cosine inverse of 0.5, now we'll get 60. But cosine inverse of -0.5, you might be expecting to get -60. The range output for cosine inverse is between 0 and pi, or 0 and 180. And so it gives you 120 degrees. So I'm just helping you understand why your calculator operates the way that it does. You don't really have to remember this much, and the application is on Wednesday. What I do need you to be able to handle is this. I need you to be able to plug these values into your calculator. So sine inverse of 1/2. We go to our calculator. We just did it. Sine inverse of 1/2 is 30 degrees. If you were to write it in radians, it would be pi/6. So I take tangent inverse of -1. I get -45. The output for arc tan is going to be between -90 and +90 as well, just like sine. So we get -45 degrees, which is same thing as -π/4. What happens if I go cosine inverse of 3? Why? It's a domain range. We already talked about you for arc cosine, you can only plug in values between -1 and +1, because the outputs of cosine are between -1 and +1. So therefore, domain error, no solution. And then cosine inverse of -√3/2. Got a domain error, so we know why. $150. I remember what that is in radians. 5/6. Okay, flip it over. All you gotta be able to do is use your calculator, okay? All right, backside, we're actually conceptually thinking about what's going on here. If I were to give you this, maybe you can tell me what sine inverse of sine of 0.3 is. 0.3. They're inverse operations, they go away. What about cosine inverse of cosine of What about sine of sine inverse of 4? Can you do sine inverse of 4? No, so we get no solution. A little tricky there, huh? Again, why do you do that? Because I'm a jerk. I woke up on the wrong side of the bed. All right, here we do sine of cosine inverse 1f. Do sine and cosine inverse just cancel out? No, so we're going to do something a little bit tricky. We're going to create a drawing. Because all of trigonometry can go back to triangles. In terms of opposite, adjacent, and hypotenuse, what is cosine? Cosine of theta is equal to adjacent divided by hypotenuse. Okay. So, this says cosine inverse of 1 over 2. What that means is this. Cosine of theta is equal to 1 over 2. Does everybody agree? If you're asking cosine inverse of 1/2, that means what angle would you take the cosine of to get 1/2? So in other words, cosine of theta is 1 over 2, or cosine of theta is 1, which is the adjacent side, divided by 2, which is the hypotenuse. Can I find the third side? How? A squared plus b squared is c squared. So I've got 1 plus b squared is equal to 4. So b squared is equal to 3. B is equal to the root of 3. Everybody got that? Now that I have my drawing intact, let's watch and see what happens. When you cosine inverse 1/2, what part of the triangle does it give to you? It gives you theta, right? If you cosine inverse a number, it gives you the angle, right? So we could say that sine inverse, we could say that sine of cosine inverse of 1/2 is the same thing as sine of theta. Everybody agree? This gives you an angle. What is sine of theta? Root of 3 over 2, because it's opposite over hypotenuse. Let's try another one. Sine is opposite over hypotenuse. So if I draw my picture, and I have theta, opposite is 4, hypotenuse is 5. Yep. So, how do I find the other side? Which will give me figure in triple. So the cotangent of sine inverse of 4 over 5, well, sine inverse of 4 over 5 will give you theta. So we end up with the cotangent of theta. And cotangent is what? Cosine over sine, or adjacent over opposite. So adjacent over opposite, 3 over 4. Tangent of secant inverse of 3. What is secant in terms of opposite adjacent hypotenuse? What's cosine? Adjacent over hypotenuse. So secant will be hypotenuse over adjacent. So hypotenuse will be 3. Adjacent will be 1. Find Find the other side. 1 squared plus b squared equals 3 squared. b is equal to square root of 8. 2 roots of 2. Tangent is opposite over adjacent. So it's going to be, yeah, so we have tangent of secant inverse of 3. Remember, when you inverse something, that will give you theta. And so when we do theta, we get tangent theta. As you said, we get root of 2, or 2 roots of 2. And the last one, cotangent. Adjacent, 12, opposite, 5. Pythagorean theorem. What do you got? 13. Boom. Cosecant of cotangent inverse, or arc cotangent 12 over 5, is going to give me cosecant of theta. What is cosecant in terms of sine, cosine, or I'm sorry, opposite, adjacent, hypotenuse? Hypotenuse over opposite, so I get 13 over 5.